Alright, Common Core Algebra 2, we are going to move on in Chapter 4. 4.3 is our next section. It's going to be about what is called factoring quadratics. And in this point, it is very important when a equals 1. So keep in mind that we're going to have some quadratic like ax squared plus bx plus c, but here a is 1, so we're really looking at things like ax squared plus bx plus c. Okay, so this whole lesson is really going to be about that. That is when a equals 1. We're also going to really quickly touch on something called the GCF, and then, like I said, factor when a is equal to 1. So first thing, what does the GCF stand for? This is nothing new for us. It's a review. GCF stands for the greatest common factor. And when we talk about a common factor, we want to think about factoring as division. Okay, factoring is really just division. So if I have an example here of 6x cubed minus 15x, what I'm looking for is what are both terms divisible by. Well, you see I can divide both the 6 and the 15 by a 3. So I could say they are both divisible by 3, and then you notice one has an x cubed and one has an x, so they are actually both divisible by 3x. So this is called our greatest common factor, or the GCF, and that should be a 3x, not a negative 3x. Okay, so when we do that, we're going to factor both terms, meaning we're going to divide both of these terms by 3x, and we're going to write that 3x outside the parentheses. So again, factoring is the opposite of multiplication. It's division, or you could think of it as the opposite of distribution. So 6 divided by 3 is 2, and if I take an x cubed, which means x, and I pull one out, now I have an x squared left. So 2x squared would be left over from the 6x cubed. I still have minus. I'm going to do 15 divided by 3, which gives us 5. And since I divided x by x, I just have minus 5 left. This would be factoring based on the greatest common factor. The really big part of today is factoring a quadratic when a equals 1. The first thing you're going to need to do is find the factors of c that sum to b, and sum means add. So again, it's going to be of the forms x squared plus bx plus c, and this only works when this number right here in front of x squared isn't written, or remember that means it's a 1. So the factors of c that sum to b are going to be rewritten as a product of those factors, meaning two binomials. Okay, and remember, a binomial is a two-term polynomial. So it's like we would have a product multiplication of two binomials. So it would be x plus or minus some number and x plus or minus some number. They could be the same, they could be different. Okay, what that looks like in practice, if I take b is negative 4 and c is negative 21, I want the factors of negative 21 that add up to negative 4. Now, if you're having trouble figuring that out, let's just start to write down some of the factors of negative 21, like negative 21 and 1. Well, that adds up to negative 20, so that's not it. I could say 7 and negative 3. And that's close. It adds up to 4, but we need to have negative 4, so this actually doesn't work either. But since my number is correct but the sign is wrong, I'm just going to switch those two signs. I want negative 7 and 3, which means I could rewrite this. So it's the same thing. I'm just rewriting it as a product of two binomials, one x minus 7, and that's because I have a minus 7 right here, and x plus 3, and that's because I have a positive 3 right here. So these two things are equal. They are the same thing. They're just written differently. It's like when you have distribution. We basically undistributed here, or unfactored, and we get the same idea again. And that is it for this lesson. So we covered two things. Our greatest common factor. Remember, factoring means division. It's like the anti-distribution. And then factoring trinomials when a is 1. So we just have something that's x squared plus bx plus c. And that is it for this lesson.